Okay, review problem 2.2. We're just going to go over these identities that we discussed in class that should be memorized. P and a true statement. Well, let's see. If P is true, then true and true is true. If P is false, then false and true is false. Either way, the truth value of P and true matches the truth value of P, and so that is just simply going to be equal to P. In other words, having the and T gives no extra information about whether or not the statement is true or false. Now, P and false is always false. No matter what P is, if I take P and a false statement, the conjunction must be true, false. P or true, that has to be true. Whatever P is, if I take or true, that guarantees me that the disjunction is true. P or false, that has to be P. Saying it's or false gives me no extra information about whether or not the disjunction is true. The next two are obvious. P and P is P. P or P is P. This is also obvious. Not P is P. Taking the negation twice gets me back to where I started. The next few are the distributive laws. And the way that, if I forget how this goes, I'll just write out to myself the ordinary distributive law. A times B plus C is A times B plus A times C. That's the ordinary distributive law from algebra. So in this case, in place of A, I have P. In place of Q, I have B. In place of R, I have C. Also, I have an or instead of a times, and I have a plus instead of an and. So I have P or Q and P or R. That's the way that this would distribute. Now, the distributive property works both ways, unlike ordinary algebra. So this one would be, if I replace times by and here, then the times here would be an and, so I have P and Q, or P and R. The next two are the distributive law also, just simply putting the third statement at the end. So we have P and R, or Q and R, Q and R. And the last one would be P or R and Q or R. And the hard part about these is just remembering which one is the or, where the or goes, which one the and goes. And for that, again, me personally, I write out the ordinary distributive law to remember how it goes. There's also the commutative law and associative laws also work for propositions. Okay, the next few. This is De Morgan's law, not P and Q. That's the same as not P or not Q. And the negation of P or Q is not P and not Q. Next, we have P or P and Q. That is equal or equivalent to P. P and Q is more restrictive than P, and so if I know that P is true, that gives me knowing that P and Q is also true gives me no extra information. Likewise, P or Q is less restrictive than P because either P or Q can be true. So if P and this is true, that's equivalent to saying that P is true. And finally, P or not P, one of those has to be true, so that's a true statement. But it's impossible for P and not P to be simultaneously true, so that is a false statement. Okay, so those are the identities here, and you should be able to do these with truth tables or be able to just simply state these from memory.